So we are going to spend a few minutes talking about the standards that we work with for modeling multiplication and division. We have 4 supporting standards: 3.4D, 3.4E, 3.4F, and 3.4J. But before we jump into that, I want us to think about, what do second grade students learn? So in second grade, they are introduced to multiplication and division concepts. And here's what I mean by that. Second grade 2.6a, students model, create, and describe situations where equal sets of concrete objects are joined. So they work with equal groups. And it's concrete. Now, they also describe things such as 6 cars each have 4 wheels, so that would be 6 groups of 4. That would be 24 wheels. They do not write a multiplication sentence for this. They do not write a multiplication sentence. So please don't say, oh, if those second grade teachers would have just done their job, then kids would know how to write multiplication. They don't. So that means they don't write this in second grade. They write 6 groups of 4 equals 24. They write groups of. They don't write the symbol. So please don't expect that they're going to come to you understanding what this symbol means. They do understand groups of. So also in 2.6b, same thing for division. Students learn in second grade that they model, create, and describe situations where a set of concrete objects, again, is separated into equal sets, but they do not relate it to division facts. So they make equal sets with concrete objects. They do not write a division statement. So they've never seen that before. They don't know what this means. Either one. They don't know the multiplication symbol. They don't know the division symbol in second grade. They learn all about equal groups. So they would say 24 broken into 6 equal groups equals 4 groups. Or sorry, 4 in each group. So third grade, what do we do? Well, we start by 3.4D, determining the total number of objects when equally sized groups of objects are arranged in, are combined or arranged in arrays up to 10 by 10. So let's say we wanted an array that is 6 by 4 to go with the example that we've been using. It would look like this. Here's the thing. The kids need to do the building of this, not just watch you do it. So they could say that this is 4 columns that each have 6 in them. Or they could say this is 6 rows that each have 4 in them. There are equal groups. So it's an array no bigger than 10 by 10, and they need to see the equal size groups that make that up. Now, when we look at 3.4e, we're representing our multiplication facts in several different ways. So this was our 6 by 4 array. We could represent that same thing with repeated addition. So it would look like 6 plus 6 plus 6 plus 6, or 4 plus 4 plus 4 plus 4 plus 4 plus 4. If we go back to that car example, this would be car 1 has 4 tires, car 2 has 4 tires, car 3 has 4 tires, etc. So there are 6 cars, each has 4 tires. So this would be our repeated addition example. Equal sized groups, usually we see students start out with circles. So if we keep using our car example, this would be car 1 would have 4 wheels. Car 2, 4 wheels. Car 3, 4 wheels. Car 4, 4 wheels. Car 5, 4 wheels. And car 6, that circle's not near big enough, 4 wheels. So that's our equal groups. We looked at an array already. An area model is very similar. We'll get more into area models when we move to larger numbers. So an area model is where we would have, I should have kept using the same example, where we could build the groups inside our area model. Equal jumps on a number line. Wonder where I'm going to draw that. Here I'm at 0, 4, 8, 12, 16, oh, I barely made it long enough, 20, 24. And they would see that each time they're making a jump of 4. And this ties to repeated addition. It ties to skip counting. It ties to their equal groups. So those are the ways that we are expected, skip counting being one of them, to represent our multiplication facts. In 3.4F, students are expected to have automaticity. Now, automaticity means I can recall that fact without having to think about it. It's automatic. Kind of like when you drive a car right now. Have you ever made it all the way home and you think, how did I get here? I don't remember driving home. Right, because it's automatic. It's automaticity. It's in your long-term memory already. You don't have to think about it. You get in the car, you put your phone down and plug it up, you turn the car on, you push the brake in, you shift to drive, you start driving. You make it all the way home, but you're not thinking about how much do I turn the wheel, when do I do this, when do I do that. It's automatic. For students, we need the recall of facts to become automatic, up to 10 times 10. Now, here's what we don't want. We do not believe in a timed test model in our district. There is a lot of research that shows how damaging that is to kids and their ability to put something in long-term memory. Long-term memory takes time. It doesn't equal speed when we're trying to learn it. Now, the way we learn this is through 3.4E and D, all of these different models. The way we learn it is by modeling it in all these different ways. Then we can move it to long-term memory for automaticity, not just expect that fast facts and how quickly can I click buttons is going to make something automatic. The way we move it from I don't know it yet to known with automaticity is through modeling. It's that concrete, pictorial, abstract. What we're looking at here, most of these are concrete. When we move to arrays and area models and pictures of things, number lines, that's pictorial. When we move to automaticity recall, that's abstract. So we have to start with the concrete, and they have to get good at that before we'll ever move to automaticity. So this takes time, and it doesn't take speed races. Okay, 3.4J, I'm going to point you back to 2.6B. Students learned the relationship in second grade between multiplication and division. They just learned it through equal groups. So they understand already how these two things are related. They have not done it with symbols. So students just need to understand, if we go back to this example, we have 6 cars that each have 4 wheels on each one. So that's 6 groups. Each has 4 in it. That's a total of 24. We could also say we have 24 wheels here that are shared equally between 6 cars. How many wheels are on each car? 4 are on each car. So we have to break it apart like that for students to see equal size groups in that way as well. we always want to relate that to fact families, related facts, turnaround facts. That's all relating. That's all the relationship between multiplication and division, just like we have the relationship between addition and subtraction. So that's what this standard is all about.